In this lesson, you will learn to work with two-way frequency tables and how to find the probability using the addition rule. So let's first look at this two-way frequency table. It is a survey of boys and girls, whether they like math or science. So with a two-way frequency table, the numbers here in the center are called our joint values. Joint values. And the numbers here in our total columns are called our marginal values. So those are our marginal values. So let's talk about just basic probability. We can use the table to find the probability of a boy. So in this survey, there were a total of 24 boys out of the 50 people. So it would be 24 out of 50. Probability that someone liked math, so the total of people that responded liking math is 22 out of, again, the total number is 50. So let's find the probability of a boy and liking math. This symbol, the upside down U, represents an intersection, so that is and. So we want to find the probability that they are a boy and they like math. So let's take a look with the highlighter here. Here are the boys that responded to the survey and liking math. So if they are a boy and they like math, notice that is 10, the intersection, so it's where those columns and rows intersect. So 10 out of the 50. Let's look at another intersection. What's the probability of a girl and they like science? So here we have girls and liking science. Again, look at that intersection. The girls and that like science, there's 14 where those rows and columns intersect out of the total 50. So that is some basic probability using a two-way frequency table. Now let's look at some other probability. This one here, we have a bag that contains 3 green counters, 2 blue counters, and 5 yellow counters. So we have to have our total first of all. So 3, 2, and 5. Let's add those together. So that gives us 10 total. We want to find the probability of selecting a green or a blue. So the chances of getting a green, there were 3 out of the 10. Or, so if it's a or, take a look with our union, we will add when finding the probability of an or statement. So probability of green or blue, so blue, there were 2 out of the total 10. So to get a blue or a green, you'll add those together, so that's 5 out of 10. Let's go ahead and simplify this fraction. So in our calculator, if you don't know how to reduce 5 over 10, you can hit 5 divided by 10, or even alpha y equals and put in 5 over 10. You'll have to hit math, option 1, which is fraction, and then press enter. So we see that it does equal 1/2. So hopefully you knew 5/10 is 1/2. Let's write it as a decimal, which we do see 0.5. If you need to change your fraction to a decimal, you can hit math. Option 2 will change it to a decimal. And so as a percentage, that is 50%. So for this situation, the chances of getting a green or a blue counter, well, since that's half of the bag, it does make sense that that's 50%. Let's take a look now at this next one. Using a standard deck of 52 cards, we want to find the probability of selecting a red card or an ace. So a red card, that's half of the deck. So that's 26 out of the 52 cards. Or, so because we're finding an or, we're adding an ace. Well, there's 4 aces in the deck of cards out of the 52. Well, notice here with our union, an or statement, we are going to add the probabilities of each event happening, but then we also have to subtract their intersection. So when they both occur, so in this case, a red card can be an ace at the same time. There are actually 2 that are red aces. So because we've counted those cards in both of these events, we've counted the red cards, we've counted the ace cards, but those red aces, we've counted them twice, we'll need to subtract out that intersection. So we'll subtract out the 2 of those 52 cards. Of course, that didn't happen in the previous question because a green or blue, you can't have an event occurring at the same time in that situation. It's either going to be green or blue. But in this situation, the card could be red and an ace, so that means we have to subtract out that intersection to find the correct probability. So because we have like denominators, a lot of times I like to just add our numerators. 26 plus 4 minus 2, that gives us our numerator, which is 28 out of the 52, and then we can reduce that fraction. Of course, you could type all 3 fractions in and calculate it in the calculator if you would like. So 28 out of 52, math fraction, or even the alpha y equals, it reduces to 7 over 13. Changing that to a decimal, we get 0. If I'm rounding to the nearest hundreds, so it would be 0.54, and so that's 54%. So the chances of getting a red card or an ace is just a little bit more than half of the deck, so 54% of the chances there. Example number 7. The table shows the results of a survey at an amusement park when 20 people were asked if they would prefer bungee jumping or riding a roller coaster. We're going to find the probability of a girl at the park or a person that likes roller coasters. Well, notice in this table, it does not have your totals, your marginal values. So you will need to find those if they're not already calculated for you. So just add a column and add a row of those totals. So here, total of bungee jumpers, we have 7. Total of roller coasters, 13. Boys, 10. And girls, 10. And so the total should be 20. So you can total your 10 and 10 to make the 20, or the 7 and 13 should make 20. So both columns and rows should have the same total value. So let's use this table now to find our probability. So we want the probability of a girl, or that's a union, a person liking roller coasters. Well, first we have to find the probability of a person at the amusement park being a girl. So here for our girls, we have 10. So 10 out of the 20. So that was that row there. So 10 out of the 20. And then we've got our probability of liking a roller coaster. So that here we have 13 out of 20. But we have to subtract their intersection. To find the probability of our union, we are going to find the probability of the event A, so that's our girls, plus the probability of the event B, so that's the roller coaster. But then we have to subtract that intersection where we're counting things twice. We don't want to double count. These 8 we'll have to subtract because we've counted them both in here as the girls and the roller coasters. So the intersection, 8 out of 20, we need to subtract that intersection. Again, because we have like denominators, we can just add and subtract those numerators. So 10 plus 13 minus 8 gives us 15 out of 20. We can change that to a fraction, which is 3/4. And of course that decimal is 0.75. And then finally our percentage is 75%. So the probability of a girl at the park or a person liking roller coasters, at 75% of those people that were surveyed. Let's take a look at this last one here. We have a group of 23 juniors and 31 seniors that are surveyed. From the students surveyed, 41 students like math and 11 juniors like English. We'll need to create a two-way frequency table before we can actually find our probability. So it gave us some information, but we will have to set up the frequency table on our own. So let's use these values. We have a group of 23 juniors. So in your juniors column, we have 23 and 31 seniors. So in our seniors column, 31. From the students surveyed, 41 of them liked math. So in the math row, we have 41 and 11 juniors liked English. So in your juniors column, we had 11 of them liking English. So take a minute and pause the video to try to fill these in and then come back and check your answers. So let's start finding these values. Well, we can add our totals so we know our total amount. So 31 plus 23, we have 54 total students. With that total, we can find the number of students that like English since we already know how many like math. So subtract the 41 to get 13 that responded to English. So with that number, we can now find how many seniors responded to liking English. Since we know 11 of the juniors did, 13 take away those 11. We'll have 2 of those seniors. Then since we know the totals of the senior and junior columns, we can figure out how many of those responded to math. So 31, if you take away 2, that gives us the 29. And then 23, take away the 11, gives us 12. Be careful to calculate your columns and rows and make sure all your math adds up before using this data to calculate probability. So it would be good to add together the 29 and 12 and make sure it really does equal the 41. 2 plus 11 really does give us the 13. And then check your columns as well and make sure all your values match up before using this information. And of course you could do your totals 41 and 13, and the 31 and 23. So it's always a good idea to check that and make sure it's set up before moving on to calculating your probability. So let's find the probability that a student in this survey is a senior or that they like math. Well, the chances of a student in this survey being a senior, so here are our senior students. There are 31 out of the total 54. We're going to add that with the students that like math. So that is this row here. So we have 41 students liking math out of the 54. But when you subtract that intersection, the students that like math and they are seniors. So those 29 students out of the 54. So we can calculate 31 plus 41. Take away those 29. We have 43 out of 54. Pretty certain that does not reduce. Math decimal. If we're rounding to the nearest hundredths place, the 6 would make that round up, but because it's a 9, it actually makes this round also here in the tenths place. So 0.8, or even 80, and so that would be 80%. So that was the probability of our seniors or students liking math. And remember, because they overlap, because they have an intersection, we have to subtract out that intersection of both seniors and math. Let's take a look at one more. What is the probability of juniors? So we want our juniors or liking English. So our number of juniors, we have 23 out of the 54. Students that like English, there are 13 out of 54. But keep in mind, because we have the intersection there, those 11 we'll need to subtract in order to find the correct probability. So 23 plus 13, take away 11, gives us 25 out of 54. I'm pretty sure that does not reduce, which it does not. Math decimal, rounding to the nearest hundredths, we get 0.46, so that is approximately 46%. So you have better chances of selecting a senior or someone that likes math other than selecting a junior or someone that likes English. There's quite a few that meet in that senior and math category, which makes sense because so many more responded to liking math, and you also have more seniors than you had juniors, so it does make sense. Always look at your answers for reasonability as well.